All right, our objective for today, I can solve two variable equations. Read together. 1, 2, 3. I can solve two variable equations. So tell your neighbor what the concept for today is. Two variable equations. Exactly, two variable equations. So no, we're no longer in one variable equation. We're in two variable equations. So let me give you a quick roadmap as to where we've been so far throughout the year. We started the school year by me showing you a video. Remember when I planted the rosemary bush? And that gave us an introduction to zero pairs, expressions, because we started dealing with real numbers. Remember? I introduced real numbers. From there we did integers, and we did a bunch of stuff with zero pairs. Then we did addition, subtraction, multiplication, and division of a bunch of numbers. From there, we got into including variables, so that means we did expressions that were numerical or algebraic. Remember that? And then from there, we did an introduction with using the pet shop. Remember the pet shop? So we introduced polynomials, and those are still expressions. Remember that? And then polynomials, we did what? We added polynomials, we subtracted polynomials, and we multiplied polynomials. Which one are we missing? Division. That's coming up pretty soon. And then from there we went into simplifying expressions using the order of ops. Yes. So once we got with all that, one of the things that I said that expressions only do what? Simplify. And some of you noticed that I wasn't using equal signs. Remember that? I was just using what? Arrows to indicate that they were expressions. From there, I said, okay, let's move on. We're no longer in expressions. We went into equations. On equations, I said, let's start with one variable equations. And we did a bunch of stuff. We did one-step, two-step, multi-step, absolute value. We graphed word problems and such. Remember that? And then I said, now that we're done with equations, we're going to inequalities. And we did the same thing. But they were all in what? And today we introduce two variable. Yay! Funner stuff. So, this is where we're at, and this is where we're going to take off. Ready? So with that said, copy this. Two variable equations. And look at the definition. Can you read the definition for us, Sergio, out loud?
Mathematical statements where two mathematical statements where two expressions are equal to each other and contain two ordinals.
Thank you. He said mathematical statements where two expressions are equal to each other and contain two unknown variables. What? I am nice. I copy that. Now, who notices that that definition sounds really familiar, right? Yeah. From the what? Okay. What? Santi. No. Yes, but they were saying, do we copy the blah, blah, blah? No. Okay? Examples. Copy this. 3x plus 6 equals 3y. 12x equals 4y minus 8. 2a plus 2b equals 14. Negative 3n equals m minus 6. Y equals x squared minus 9. Copy those. Then I'll go over the definition, including the examples. So according to the definition, look up please. According to the definition, it says mathematical statements, and the key part here is that we remember is that two expressions equal to each other. Remember that? And then the last part is two variables. They contain what? Two different variables, two different unknowns. So let's see. Expression, expression equal to each other, two different variables? Yes. Same here. Expression, expression equal to each other, two different variables? Yes. Expression, expression equal to each other? Yes. Two different variables? Yes. And so on and so forth. Straightforward, right? Non-examples. X plus 2, 12 equals y minus 8, and 2a greater than 14b. Those are non-examples. So what I want you to think about and not say it out loud is, what is the name of each of those non-examples? If it's not a two-variable equation, what is the name of this one, the name of this one, and the name of this one? Discuss it with your neighbors, please. What are the names of those non-examples? All right, let's see. What's the name of this one right here, Vaz? He said an expression, but what is the specific name of this expression? Not quite. He said one variable expression. No. Yes, Julia. Doesn't have an exponent. Dylan. Algebraic expression. As soon as it has a variable, numbers, and operation, it's algebraic. How about this one right here? How about Vaz?
It's a one variable equation.
One variable equation. Why? And it has two expressions equal to each other. Guys, focus, please. And the last one example, what is this one called? Vaz.
Inequality.
Close. It is an inequality, but what specific name is that one?
Two variable inequality.
Because it has two different variables. That is correct. Everybody catch that? So therefore, these are two variable equations because why? Tell your neighbor. What would be the most important thing to remember? So yes, they need to have an equal sign and two unknown variables. Write that in the critical attributes. And for today, remember in the past when we saw for equations and inequalities, the 4 steps? Everyone, what are the 4 steps? Simplify. So today we're going to use the first 2 steps, not the last 2. So the first 2 steps are simplify each side of the equation, start with grouping symbols and combining like terms. Step 2, isolate the variable by using the inverse operations. Copy that, please. So 2 steps that we're going to focus on today is simplifying and isolating. That's it. And you'll see why right after this. Check this out. So once again, you already know what 2 variable equations are, right? There's no doubt about it, right? But today, I'm going to introduce one more equation that looks something like this. Look up, please. You don't have to copy this. Pay attention. For example, in science, you're using different formulas already. Is that correct? Pretty soon, you're going to be using this one, or you are already using it, which is the distance formula or rate formula. Now, check this out. At this moment, this formula right here is solved for the letter D. Notice that the D is by itself, and it's equal to these. Therefore, it's already solved. But what if I said, you're only paying attention, what if I said D equals rate times time, and I wanted you to solve for the letter T? So this is what you would do. Line down the equal sign, pay attention, or you're going to miss it. This is going to go pretty fast. What's next to the T? What operation? So the inverse is divide. We're left with D over R equals T, and now it's solved for T. Now, so pay attention. The process is the same, and it's kind of like For those of you that are Star Wars fans, remember episode 1 where, I'm not episode 1, episode 4, New Hope, when Luke Skywalker is about to shoot down the black, what's that called? Death Star. And all of a sudden, he's about to put on his goggles so that he can see the where he's going to shoot. And all of a sudden, he hears Obi-Wan Kenobi, use the Force, Luke. He's all, what? Use the Force. And it's the same thing. Here, the processes that you've been learning with this, it's going to pay off because you already know the process. Even though, notice, are there any numbers here? No. Now, this particular equation has a particular name. Who notices that this is not a two-variable equation? This one has more than two. This is called a literal equation. Literal equation. So, in order to distinguish two-variable equation from equations that have more than two variables, they called it a literal equation. Are we there so far? So, what's the difference between a two-variable and a literal? So, let's see. I need a volunteer. Somebody give me a two-variable equation. Okay, go ahead, America. What'd you get? Yeah, give me an example. 3x. 3x equals what? Plus 6 equals 3y. Does everybody agree that's a two-variable? Okay. Can I get a volunteer to change that one into a literal equation? Literal equation. Jonathan.
3x plus a equals 3y.
Hands if you agree that's a literal equation. That is correct because it has how many variables? At least 3 or more. Are we there? Does everybody understand the difference? Julia.
Yeah, it said 2 more.
Right. Well, this is a two variable, and yeah, Julius is right. Does everybody see that? It says an equation with 2 or more, it's a literal, but from now on, whenever we see anything more than 2, it's a literal. 2 or more. Let's leave it at 2 or more. Okay, copy this. It's a two variable. It's also a literal. Yes? It's both. Don't write anything. Copy these. I'll clarify it. Copy that. Example 1a, solve x plus y equals 15. For x, and solve b, pq equals x for q. So let's do these two together. For a, here goes step 1. There you go. I already got you started. And we're solving for x. So we need to get rid of y. Everyone, what do? Minus y, x equals, look up please, look how I'm going to write this. Tell your neighbor why it's in this order.
I don't understand.
Yes, it's in standard form. Whenever you're manipulating equations, guys, especially for two variable equations, I want you to write the variable first and the constant at the end. So it's in what? Standard form. Okay, let's do this one. We need to solve for Q. What's next to Q? P, and what operation is that? Multiplication, so therefore we divide by P, divide by P. We're left with Q equals X over P. Yes. For which one? For X?
Yeah, like put negative 1 plus 16 instead of that.
Over here? Oh, you mean substitute into the original one? Yeah, because basically you're getting the same thing. But I know where you're going. Good eye. go to the next one. Copy this one. Example 1C. Says solve 5 minus b equals 2t for t. See if you can do this one by yourself. And be careful. Well, actually, no, this is a straightforward one. I'll help you with the first step. There you go. You're welcome.
That was so helpful, I can't understand now.
Okay, thank you. We're solving for t. What's next to t? So what do I do? Divide by 2. Divide by 2. 5 minus b over 2 equals t. Hands if you got that. Okay, so if you want to simplify it, what would be the simplification of that? Seabest.
5 divided by 2.
Which is 2.5 minus b over 2 equals t. Or could we change this to 1/2 b also? Either one. Either one is correct. I'll take either one. Yeah. If we're gonna write it like this, is this standard form?
No.
So therefore, what do I do? Negative b over 2 plus 2.5 equals t. However, if you leave it like this is how it stays. If you don't simplify, it stays like this. Give me a second. Copy this one, please. 5 minus b equals 2t. And this is example 1Q, but I want you to solve for b. It has a little curveball. See if you catch it. Don't say it out loud if you see it. Go. I'm going to go over this one just to make sure everybody's on the same page. So line down the equal sign. Focus. So I'm solving for b, which is here. Here we have two different operations. The first one is addition. The second one is multiplication. What's in front of the letter B? -1, it's multiplying, right? And what is this other one? Addition. So how do we get rid of this? Subtract 5, subtract 5. Bless you. We're left with -1b equals 2t minus 5. And at the end, divide by -1, divide by -1. b equals -2t plus 5. Hands if you got that one. Okay, not bad. Not bad. All right. Yeah. If you left it like this? Yeah, if it's a 1, might as well do the simplification. Let's go to number 1D. Copy this one. Solve D equals M over V. Be nice. So we're solving for V. Now, yeah, I know this is a little bit confusing because now the V is the one dividing, but yet we need to solve for V. Well, let's manipulate it. Isn't this a scale?
Yeah.
Can we move stuff around first so we can start leaving one variable by itself? What do I do? Multiply times V. Multiply times V. VD equals M. And then?
Divide by 2.
Did everybody see it? Well, yeah, but you need to show the work so that I can see what that you're just not. Oh, I'll just switch it. All right. Let's see. This one really quick. 20 seconds. A equals B over C. Solve for C. Let's see how you do. Wow. Focus, please. Okay, what'd you get for this one, Chris B? C? Hands if you got that. That is correct. And the last one. Copy this one. It says, hold on. It says the formula for the area of a triangle is A equals half BH. Copy that, please. Copy the formula. You don't need the instructions. A equals half BH. And then they describe each letter. But look what they're asking for. What are they asking for? Solve for H. See if you can do that one by yourself. Go. Solve for H. I'm going to get started just to for the sake of time. So I need to leave H by itself. First, I'm going to get rid of the letter, which is next to it, the B. So I'm going to divide by B, divide by B. I'm left with A over B equals 1/2 H. Are we there so far? Yeah. Okay. Some of you started with the half. That's fine. How do I get rid of this half? Multiply times 2 times 2. Therefore, 2A over B equals H. Hands if you got that. What's that? No, because this is the fraction times 2. It multiplies times A only because it has a 1, right? Home play for tonight is found on page 111. Good one, guys. Enjoy your home play. See you guys tomorrow. Others tutoring today. Bye.